All right, so today we're going to talk about rational exponents a little bit more. I made mention last time that there's a link between these rational exponents and radicals, and today we're going to take a look at that link. Okay, so the point of today is to be able to use properties of exponents and also properties of radicals to simplify expressions. Now, we've always been in the habit of changing forms. Whether we're talking about fractions to decimals, sometimes it's helpful to have a fraction 1/2 if you're talking about graphing a line and slope. Sometimes it's helpful to change that 1/2 to a 0.5, make it a decimal, sometimes to make calculations a little bit easier. All these are examples of changing form. Standard number to a scientific notation, and science uses that a lot just because some of their numbers can get so large, but being able to write it a little bit more concise or a little bit more condensed version is helpful. We've changed standard form to vertex form for parabolas to help it a little bit easier to graph. And then you've always been able to change decimals to percents and percents to decimals, just fitting whatever need that you have, right? So that's what we're talking about, just changing form, right? Rational exponents is not a lot of meaning as far as evaluating that is concerned. So turns out that you can change the form of a rational exponent. And you can change that into a radical. In radicals, we have a little bit more of a mechanism for evaluating, simplifying. The way this works, the base of your exponent becomes the radicand of your radical. The denominator of your rational exponent becomes the index for your radical. And then the numerator for your fraction exponent turns into the power that we're going to raise the entire radical to, right? So it becomes sort of a switcheroo kind of deal, right? A to the m over n. The n kind of comes over here and becomes your index for your radical, and then the m kind of falls down a little bit and becomes the power on your radical. So I had someone explain this to me one time. It made sense. The roots of your radical, roots are in the ground. You got to be at the bottom to be near the ground. So that needs to be the bottom of your fractional exponent. This is kind of a way to kind of keep track of that. Okay? But that's how we're going to change these. So just getting in the sort of the habit of what it would look like when we change from a rational exponent to a radical. Okay? Here the denominator becomes the index. The numerator becomes your power. And so we go the square root of 7 to the third power. I wanted to write the 2 in there just so you knew where the numbers were going. But, you know, for a square root, we typically don't write that 2 in there. And so it would look like this. Okay? Same thing for the next one. Your denominator becomes the root, right? The bottom is the root. The base is the radicand. And then, of course, to the first power. But we would not write that in there normally, just be the 5th root of 11. Okay? Give you a couple seconds of a head start to write the next one. Give it a shot. You don't necessarily have to stop the video. I'll give you a second to think about it and start to write it. Okay, are you starting to write the 7th root of 12 to the 4th power? That's what it should be. Okay? And we'll take a look in a second when it's going to be helpful to rewrite these. Okay? Now, we need to be able to go the other way. Sometimes it's helpful to take a radical and write it as a rational exponent. We'll talk about when that is in just a second. But it's the same thing. So here's your root. Roots are in the ground. It needs to go to the bottom. So 2 becomes the base of an exponent. That is 3/7. So 2 to the 3/7 power. Okay? Really careful here on the next one. What is actually sitting there, even though you don't see an index? It's not a 1, it is a 2. So slide that over and make this 15 to the 5/2 power. Okay, I'll talk and move slowly to the third one. Let you try to write it out before I get there. So what would that look like? We're going to move the 5 over here. the radicand becomes the base, and your fractional exponent is 7/5. Okay? Good. And that's just rewriting. And the idea is to be able to help us evaluate or simplify an expression. All right? Sometimes it's helpful to rewrite, sometimes it's not. It's just a matter of whether you get stuck or not. So how we would evaluate these radicals, since we're raising a radical to a power, it's pretty simple. We can just take the cube root of 125. If you don't remember how to do that by hand, right? If you don't remember what the cube root of 125 is, you can always break this guy down into its factors. It does take 3 to break one out of jail, so we're going to use all 3 of these 5s to get one guy out. So 5 comes out, nothing goes back inside the radical, so the radical's gone. We just got to do 5 squared, which is 25. Okay? Kind of the same thing here, right, where we're going to evaluate this first. 4th root of 16, if you don't know that it's 2, you can always, again, break this down into its factors. It's going to take all 4 of these 2's to get one out. So we get 2 to the negative 6th power. Now, negative exponent, so we got to drop that down into the denominator of a fraction, so 1 over 2 to the 6th. Of course, we want to multiply out 2 to the 6th because we can. So 2, 4, 8, 16, 32, 64. It's just 1 over 64. Okay? All right. Just a heads up, you're not going to be able to use a scientific or a graphing calculator on your quizzes or tests with this. So make sure that you're doing this by hand or with the 4-function calculator if you need it. Okay? All right. One more. You try to simplify this. I'll give you a couple seconds. You can stop the video if you want and then get it going again to see if you're right. So, did you get 81? Reduce that radical. And the cube root of 27 is 3. Then we're going to raise that to the 4th power and get 81. Okay? All right. Now, how does that help us with our rational exponents? Again, 8 to the negative 2/3 power doesn't have a lot of meaning. One thing we do know is that since this exponent is negative, we're going to drop this into the denominator of a fraction to make that exponent positive. But still, I don't know what 8 to the 2/3 power is, so I'm going to go ahead and rewrite this as the cube root of 8 squared. The cube root of 8 if you don't know, you can always break it down into its factors. I'm going to stop doing that at this point and just say it's 2 squared and get 1 over 4. So 8 to the negative 2/3 power is simply 1 over 4, 1/4. Okay? We can do the same thing with this next guy. Rewrite right? Careful. It's an odd root, 7th root, so a negative is okay. You don't have to worry about pulling an I out, but we are going to pull a negative out. And the 7th root of 128 is 2. So we're going to raise that to the 3rd power. Again, you can always break down into factors to figure that out. It's going to take 7 guys to break one out, so 128's got 7 factors of 2. But negative 2 to the 3rd power ends up being negative 8. Okay? No problem. You try. Go ahead and rewrite and then simplify from there. Did you get 125? You're going to rewrite this as the square root of 25 to the 3rd power. That is 125. So square root of 25 is 5. 5 cubed is 125. Okay? Now, we're going to start looking at trying to simplify more complex things. So adding some operations, these multiplying, dividing, things like that. The pretty good rule of thumb here is if you can't figure out how to simplify what you're looking at, rewrite it. Change the form and see if changing the form gives you some ideas. Things you want to look for. in order to be able to multiply or divide radicals, the index has to be the same, right? If the index is not the same, then you cannot multiply radicals, you cannot divide radicals, so maybe rewriting into exponential form is going to be a better way to go, right? Now, for exponents, in order to be able to multiply, divide with our in exponential form, you have to have like bases. So if you're looking at something in exponential form and the bases aren't the same, you're not going to be able to add and subtract those exponents like we were doing in our homework before. You have to rewrite into radical form, and hopefully something in we can do something in radical form. Okay? So let's put this to the test. The first one here. If you look, this is the base for the exponent 1/3. This is the base for the exponent 1/3. Those bases are not the same, so we cannot add those exponents, 1/3 plus 1/3. So the only thing we can do to try to simplify this is to rewrite this into the cube root of 4xy to the 5th times the cube root of 16x to the 8th y. Now you can multiply those two radicals together. Before you do that, you could always simplify and then multiply together. We did this last semester, right? The cube root of 4, we're not going to be able to do anything with that. X's, 3 will not go into 1 at all, so the x has to stay in here. But 3 will go into 5 one time, so we're going to pull 1y out with 2 left over, so 2 y's go back in. And then for the next guy, the cube root of 16. We can break 16 down, get 2, 8, 2, 4, 2, 2. And it takes 3 guys to break one out of jail. So those 3 guys are going to get that 2 out, the other 2 has to stay. So 2 comes out, a 2 stays in, and then our x's. 3 goes into 8 twice. So I need more room here. So 2 x's come out with 2 left over. And then we're going to multiply together. So outside times outside gives me 2x squared y, cube root of 8x to the 3rd, y to the 3rd. And then we got to go through another round of simplifying. The cube root of 8 is 2. So I'm going to get 2 times 2. And then 3 will go into 3 one time. So for the x and the y, I have to pull one more x out. So that means I'm going to have 3 x's out here and 2 y's out here. And so we get 4x to the 3rd y squared. If that's a little bit more of a confusing way, you can always just multiply right off the bat and then go simplify. Okay? Same thing with the next guy. These bases are not the same. So we need to rewrite into the 4th root of 54 times the 4th root of 48. Now 54 times 48 gets kind of big, so I am definitely going to try to reduce first. So 2 goes into 54 27 times. 3 and 27, 9. 3 and 9, 3. All right, it takes 4 to break one out, so I'm not breaking anybody out of jail there. So 2 goes 24, 2 and 12, 2 and 6, 2 and 3. It does take these 4 2's to break one out, so I can get a 2 out in the second radical, but a 3 has to stay. Now when I multiply together, outside times outside, I get 2. 4th root of 162. And I got to do the same thing for 162, which goes 281, 327, 39, 33. Takes these 4 3's to break one out. So I'm going to get a 3 outside with the 2, and I got to put a 2 back in. So we get 6 4th roots of 2. Okay? Could not simplify originally in exponential form, but once we changed it, we could work with it. That's the point. Okay? A few more here for you. Okay, the cube root of 384 to the 1/3 power, 6 to the 1/3 power. Again, the bases are not the same, so we cannot subtract those two exponents. So we rewrite in radical form, cube root of 384 over the cube root of 6. And I do that because now that the index is the same for my radicals, I can actually merge those into one giant fraction and get the cube root of 64. Cube root of 64 is going to be 4. Again, break it down with its factors and get that if you need to. Just for time purposes, I know that the cube root of 64 is 4. Okay? All right, same for the next. Hopefully you kind of have started looking at this already. I've got to change this because the bases are not the same. Now merge those. And 14 will go into 70 5 times. And so I'm left with the cube root of 5. And we're done there. Okay? Now, look at when it's in radical form. These indices are not the same. The index for those two radicals are not the same. So we cannot multiply those two radicals together. So what we're going to do instead is rewrite these in exponential form. Remember, this is a 2 over here with the 1. So we get 7 to the 1/2 power times 7 to the 1/3 power. Now if we're going to multiply, now we have like bases for our exponents, we can multiply those. We just have to add the exponents, get like denominators. And so we get 7 to the 5/6 power. Same thing for the other guy. The index for our radicals are not the same, so rewrite. I said rewrite. Then we go through and add our exponents together. Get like denominators. And so we get 8 to the 11/15 power. Okay? All right. Not a lot more complicated here, but I do want to show you something with this next example that might help you shorten your work a little bit, which I imagine you're interested in. All right, so index, not the same. We need to write these in exponential form. So the numerator would be x to the 3rd y, all of that raised to the 1/4 power. The 4 comes all the way out here. Over x squared y squared, all to the 1/3 power. But remember that when you have an exponent outside the parentheses like this, you can distribute. That's what we want to do. So 1/4 times 3 is going to give you 3/4. So x to the 3/4 power, y to the 1/4 power in the numerator, and then 2 times 1/3 is 2/3. And now, can you make a connection between how we get from here, or to here, from here? And you see what happened? Instead of bringing the index all the way out, we can just make it the denominator of a fractional exponent for all of our individual pieces. X to the 3/4, y to the 1/4, x to the 2/3, y to the 2/3. And it's a way to kind of cut out this part if you don't want to have to go through that. Okay? Now, we do need to go ahead and keep simplifying. So, like bases there, we want to subtract 3/4 minus 2/3. Got to get common denominators, which is going to be 9/12 minus 8/12, which is 1/12. So we get x to the 1/12. And then for the y, we get 1/4 minus 2/3. So this is going to be 3/12 minus 8/12, which is negative 5/12. So we get negative 5/12 power. The y has a negative exponent. We've got to drop him into the denominator of a fraction to make that exponent positive, and then we're done. Okay? So, kind of cutting out the middleman in this next guy, we're going to rewrite these as y. Again, we have to rewrite because the index is not the same. Y to the 2/5. Remember, this is a 2 over y to the 3/2. So 2/5 minus 3/2 turns into 4/10 minus 15/10, and we get negative 11/10. Then we can drop that into the denominator of a fraction, and we are done. Okay? Hope that makes enough sense. So the bottom line is, when you get stuck simplifying, try changing the form. And changing the form might help you go a little bit further, right? But that's it. So try your homework out in Canvas. Let me know if you have any questions.